So this is 1.7b in college algebra, and we are on even and odd functions on the bottom of page 149. All right, so now let's compare symmetry to functions. All right, so an even function. If the graph of a function is symmetric with the y-axis, okay, so if the graph of a function is symmetric with respect to the y-axis, we say that it's even. If a graph is a function with respect to the origin, we say that it is an odd function. Okay, nothing going on with the x-axis. Okay, so let's look at the even one, the top one there. Basically, they're saying the function of x equals the function of its opposite. And with the odd function, they're saying the function of a negative x gives me a negative function of x. And we'll go into that because there's a big difference between this and this. The negative there and the negative out there. All right? So let's go ahead and look at the algebraic procedure for determining even and odd functions, top of page 150. So rather than read all of that to you, let's just use it in example 3. So we're going to take this function, and let's see, that's 5x to the 7th minus 6x cubed minus 2x. And what we're going to do is we're going to determine whether this is an even or an odd. It cannot be both. It has to be one or the other. Okay, so let's go ahead and look at this. First step, replace or find the function of negative x. So what that means is whenever we see an x, we put a negative x in its place. Like my 70s music? Probably not. All right, so we get that. And let's go ahead and do the work here. Okay, so that gives me that. So we see that f of x does not equal f of negative x. Okay, therefore f is not a function. Or not a function. It is a function. It's just not an even function. Because remember when I had on the screen before, f of x has to equal f of negative x. Okay, so it's not even. It could be neither. It could be neither even nor odd, but we have to keep going and find out if it is odd. All right, the rule for finding out if it is odd is we have to find out if f of negative x equals negative f of x. Okay, so what did we just find out? We just found out f of negative x, so this part's already done. So we're just going to have to find out if this equals the opposite of f of x. Okay, so let's find out what this is. So we're going to write negative f of x. What is that? Basically, it's f of x with a parenthesis and a negative put out there. So let's go ahead and write that. Okay, so let's distribute this negative. Okay, so what did we find out? We found out that, besides the first mistake I made when I distributed, this needs to make that a negative right there, so sorry about that. But what did I find out? Negative function of x equals function of negative x. And that's what I was searching for right here. I was trying to find out if those two were equal. If they are, then it is an odd function there. Alright, so I wrote at the top here that this scenario gives me an even function, this scenario gives me an odd. So let's do example 3b. So I'm going to turn this off while I write that out. Okay, so there we go. So instead of using an f of x like we did up here, we're going to use an h of x, but it doesn't really matter whether that's an f or an h. Alright, so let's find, first of all, what h of negative x is. Okay, so again, we're just replacing all of our x's with a negative. And one of the things you're going to find out is these exponents that are even and odd have a lot to do with whether or not we've got symmetry or not. Alright, because whenever you have a negative variable with an even exponent, this will always change to a positive, right? So this is going to be 5x to the 6 plus 3x, whoops, I'm sorry, that should be a minus 3x. Because this gives me a positive x squared times the negative gives me that negative. Alright, so this is what I get. Is that equal to what we started with? It is. The function is even. Now I said earlier that a function cannot be both even and odd. So if you find out that it is in fact even, you don't have to go any further because you know it's not going to be odd. So why even try it? Okay? So once you find out that it works as far as being even, you're done. Okay? So we can stop. All right. And one of the things that I need to make sure you realize is the reason why we're talking about the y-axis and symmetrical is because if it was symmetrical across the x-axis, one thing that would happen is this. Let's say that we had this, and it was symmetrical across the x-axis. Well, one of the things you'll notice here, vertical line test crosses at two places. This is not a function. And that's what we're dealing with. We're dealing with functions. In fact, that's the name of this section, even and odd functions. If it goes across if it's symmetrical across the x-axis, it's not a function. So that's why we're talking about even functions across the y-axis, odd functions being symmetrical around the origin. All right, so just to kind of remind you of that. Let's go to transformation of functions, which is bottom of page 151. And basically what a transformation means is that it just moves around, okay? You've got a specific different kind of, well, let's just get a graph up here. And we've got a graph that maybe looks like this, okay? A transformation means that it moves over this way and then moves down and ends up being down here. Okay, it transformed, it moved. Trans, those of you in my English class, means across. So it moves around. So anyway, the building blocks for transformations, again, are in the last page of your book on the cover, A Library of Functions. Those are what the functions look like. Transformations means that we're going to just kind of move them around, okay? And if you look at the bottom of page 151, top of page 152, there's also the building blocks of functions. All right, so let's talk about vertical and horizontal translations. So let's say that we have a function that's given by like y equals 1/2 x. Okay? One of the things that you'll find out is that if we add or subtract a number to this, what it's going to do is it's going to shift our graph up or down on the graph. Okay? So if I have a graph And when I graph it, I get maybe this line here. All right. If I add or subtract a number, it may move this graph. It may move it down here, may move it up there. But that's all it does, is it shifts it up or down on the graph. It doesn't move it left or right. Doesn't move it on an angle. It just moves it straight up or straight down. And when it does that, it's called a vertical translation. It moved it up or down in a vertical way. So what happens here? If we have a graph like y equals f of x plus b, because of that plus sign, it's going to move it up. If this were a minus b, it would move it down vertically, just straight up or straight down. That's all it's going to do. All right, so let's go ahead and continue on with this. Okay, so vertically, we have this here. Nothing's touching this, but we're just adding a number b to it, and it's going to make it go up or down. What if we did this, and inside of here we added or subtracted a number from it? So if we subtract a number from it, it moves it right this many units. If it's a plus d, it moves it to the left this many units. Okay? So it appears to shift it the opposite way you would think it would, but in reality it really doesn't, because it's x minus d or x minus negative d, and it just gets into double negatives and stuff. But for right now, just write that down. The box on page 152 bottom, 153 middle, and let's go ahead and do some examples, and I'll start example 4 on the next video.